So, for today's video, I am going to tackle to you the chosen topics that we have chosen in Physics for Engineers. So, the topics that we are going to tackle to you is all about the physics of running. So, by the way guys, pagpasensya niyo na kung nag-e-echo or nagba-bounce back yung boses ko kasi nasa quarantine facility kasi ako ngayon because my family is a COVID-19 positive. So, simulan na natin. Let's start. So, running is one of the simplest forms of exercise we can do. It requires no protective gear or fancy equipment. At its core, it just requires force. Runners are constantly searching for clues for how to improve their speed and prevent injury. But until now, there was no easy way to fully assess the way a runner moves. So this is the physics of running. When a person runs, their body must convert potential energy into kinetic energy. So potential energy is the energy stored within our system. Potential energy is used when the system uses kinetic energy to move to a horizontal direction. In the human body, potential energy is stored in the form of chemical energy, wherein the chemical energy comes from the food that the person eat or the food that we consumes throughout the day. The body needs a certain amount of calories or the energy from food in order to perform certain activities. So kapag ang isang runner ay hindi siya nakapag-consume ng enough or ng sapat na calories throughout their day, they will run out of potential energy na kung saan nagkukos ito or it causes them to become tired. Mapapagod sila kasi kulang ang calories na nakuha nila. Pinagpapawisan ng isang runner dahil na rin sa ang sweating or ang pagpapawis ay isang body natural cooling mechanism. If the runner did not have the ability to sweat, the conversion of potential energy or specifically the chemical energy into kinetic energy, which is released as thermal energy, would cause the runner's body to overheat. The chemical energy that the runner consumes in the form of calories is the released in the form of sound energy, wherein every time the runner's foot hits the ground, energy is leaving the runner's body as sound waves emit from the impact of the runner's foot on the ground, because energy is being released from the runner's body with every step they take. So it is important for the runner to consume enough chemical energy in the form of calories prior to their run. So the runner's body needs a substantial amount of calories as a reserve so that they will have more to burn as their potential energy is released throughout the run. So the power that the runner generates during their run will depends on the amount of time it takes to complete the run. So if they decided to run a given distance, their power output will depend on how long it takes the runner to complete the given distance. So the power of the runner can be calculated by dividing the amount of work that they do during the run by the amount of time it takes them to complete the run. Or P is equal to W over T, or the work divided by the time. So if the runner completes the run in a short amount of time, they will have a relatively large power output. If it takes them a long time to complete their run, the runner will not generate as much power. So the amount of time that it takes the runner to complete the run depends on their velocity. Kinetic energy is equal to 1/2 of the runner's mass times their velocity squared. So if the runner has a mass of 60 kg and wants to run at a rate of 9 meters per second, they will use about 2,430 joules of energy. So the runner is not able to change their mass, but they can increase or decrease their use of kinetic energy by increasing or decreasing their velocity. So if the runner has not consumed a lot of chemical energy throughout their day, it would be wise for them to decrease their velocity as the less of their stored potential energy. So generally, based on Newton's second law of motion, says that the force is mass multiplied by acceleration. So, a runner's mechanics or movements can be represented by a simple waveform, a visual representation of form over time. The moment the runner's foot hits the ground is represented by the beginning of the wave, as the mass of the runner's body accelerates toward the ground, the amount of force increases and the wave climbs. So and then the wave then slopes down as the runner begins the motion of lifting the leg again. So that was the physics of learning. For further explanation po, magbibigay pa naman ako ng mga videos in related to physics of running. Para po mas lalo nyo maintindihan kung ano nga ba ang relation ng running into physics or the relation of running into physics for engineer subject.
This is world champion and gold medalist in the 110-meter hurdles, David Oliver, running at 10.2 meters per second on the SMU high-speed force treadmill. We simultaneously record ground reaction forces and video at 1,000 frames per second. To run fast, sprinters apply forces up to 5 times their body weight in less than 100 milliseconds on each leg. Here's distance runner Ryan Hall, the fastest American marathoner in history, running at 5.7 meters per second, a 2-hour and 3-minute marathon pace. He has a different force pattern, lower in amplitude and longer in duration than a sprinter. During a marathon, Ryan will impact the ground 25,000 times with a peak force of 3 times his body weight for each footfall. Running ground reaction forces thus have fundamental physical and biological significance. Is there an underlying principle that relates the force to the motion of a runner? There is. Newton's laws of motion. We determined that the motion of the body behaves as a two-mass system when running. Mass 1 consists of the lower contacting limb. Mass 2 consists of the rest of the body. An impulsive force results from the vertical collision of the lower limb with the running surface. The magnitude and timing depend on the vertical acceleration of the ankle. Simultaneously, an impulsive force results from the vertical motion of the rest of the body. The magnitude and timing depend on the contact and aerial time. The forces add together to form the total vertical ground reaction force. All force patterns are determined by just 3 motion parameters: contact time, aerial time, and lower limb acceleration. Our model accurately predicted forces across running speeds from 3 to 11 meters per second for 42 men and women with different foot strike mechanics. Applications of the model include gait analysis, robotics, prosthetics, orthotics, and shoe wear design. I'm Ken Clark. Further details of our research can be found in the Journal of Experimental Biology.
That is the end of our videos. By the way, shoutout nga pala sa napakabit namin teacher na si Ma'am Eileen Nunez. So, thank you for listening and thank you for watching. Bye!